Let's take a look at example 5, part B, in our section 2.2. Now, I want to start off by apologizing. What's in your workbook is not correct. Your instructions say in your workbook, use the synthetic division to show that x equals 2 is a 0. And it goes on to say, so x minus 2 is a factor. Those numbers are incorrect. I have written in red on this problem what your workbook is supposed to say. So we're going to use the synthetic division to show that x equals -1 is a 0 of q of x. That's the first thing we're going to do. And then after we do that, if x equals -1 is a 0 of q of x, that means that x plus 1, change the sign of that x equals, x plus 1 is a factor of q of x. And since q of x came from a synthetic division of a 0 of f of x, if something is a factor of q of x, is also a factor of f of x. So let's start off with the synthetic division. We're going to take -1 and we're going to set up our chart using the coefficients of q of x. And q of x is this green function written up here that once again came from the synthetic division of a 0 of f of x. So the coefficients are 2, 11, 18, and 9. And we're going to start off our synthetic division by dropping the leading coefficient of 2 beneath the line on the chart, and then multiplying. -1 times 2 is -2. 11 minus 2 is 9. -1 times 9 is -9. 18 minus 9 is +9. -1 times 9 is -9, and that gives us 0. So what we've just shown is that q of -1 is equal to 0. And what that means is that x equals -1 is a 0 of q of x. Now going a step further, that means that x plus 1 is a factor of q of x. And then taken all together, that means that f of -1 is also 0. Because once again, q of x came from a synthetic division using a 0 of f of x. So whatever we find for q of x in terms of zeros, they're also zeros for f of x. So f of -1 equals 0. X equals -1 is a 0 of f of x. And x plus 1 is a factor of f of x. That's what that factor theorem was all about when we started off this video. Now, part C says find the complete factorization of f of x. Now, f of x, I'm just going to write it here, it's the top of your page. Once again, it's a 4th degree polynomial, which is not easy to factor. We started off being given a 0. So that first 0 was f of 2. So to factor f of x is equal to x minus 2. So remember, you change the sign. X minus 2 times its q of x, which was 2x cubed plus 11x squared plus 18x plus 9. And in part B, we found that x plus 1 is another factor of f of x. So f of x is equal to x minus 2, x plus 1. Because x plus 1 was a factor of q of x as well. So now we're going to take the polynomial that's left over after doing the synthetic division with -1, and we're going to write it here. And it's 1 degree lower than q of x. So we have 2x squared plus 9x plus 9. And we are told to complete the factorization of f of x. So now we need to factor 2x squared plus 9x plus 9. Now we're going to complete the factorization. So if you don't want to try to factor this guy, you might want to use the quadratic formula. If we use the quadratic formula, what we're going to do is we're going to find what x equals and then put it back into the factorization as parentheses by changing the signs of the x's. So we would say, okay, this one's a nice factor, this one's a nice factor, this x squared. Let's say I had 2x squared plus 9x plus 9 equal to 0. Well, by the quadratic formula, we're going to have x is equal to the opposite of b plus or minus the square root of b squared minus 4 times a times c divided by 2 times a. So x is going to equal a negative 9 plus or minus the square root of 81 minus 4 times 2 times 9, which is 72. So 81 minus 72 over 4, which is a negative 9 plus or minus the square root of 9 over 4, which is equal to a negative 9 plus or minus 3 over 4, which then separates into two numbers. Negative 9 plus 3 divided by 4. So negative 9 plus 3 divided by 4, which works out to a negative 1.5 or a negative 3/2. And then we have negative 9 minus 3 divided by 4, which works out to negative 3. And if you remember, way up here on part A, we verified that negative 3 is a 0 of f of x. So now what I have to do is put this back into the factorization, where I have this quadratic. I now have two factors, and I need to change the signs of these x's, because this is x equals, and when it goes back into the factorization, it changes signs. So we have x plus 3 for that one, and x plus 3/2 for the other. And we have gone through the process of factoring that fourth degree polynomial down to all of its factors. And you notice that fourth degree polynomial ended up with 4 real zeros. And if we went to y equals and entered in that fourth degree polynomial way up here at the start and hit graph, you could see those 4 zeros, the 4 places the polynomial intersects the x-axis.